ThinkingScript is a project that I've been working on for the past few weeks, just kind of off to the side as I've been building other applications and reading about OpenClaw and all that fun stuff. And one thing I've been noticing about all the agents and stuff that are coming out now is they seem to just have a lot of complexity into them. And I wanted to explore the idea of, well, what if we just had executables that when you run the things, an agent kicks them off, it does this thing, it tries to make sense of whatever the script is, and it eventually tries to compile something that maybe it doesn't need an agent. If I want to print hello world to the screen, I don't really need AI to do that. So that's what ThinkingScript tries to do. And let's dive in and have a quick look. So to install this thing, we're going to just go ahead and hit install there. We copy the installation and we go into a command line. Actually, I need to copy this. All right. So we're going to install this thing, and then of course you have to set it up. We're going to give it an API key, and of course right now it takes an Anthropic API key. I don't think that copied. All right, there's the key. We're going to run the Sonnet 4.5 model. I actually don't know if that's recommended. That's just the one I've been using it, so there's the recommendation. And let's try this thing out. So the cool thing about ThinkingScript, you run programs with the think command, and you can give it URLs. So think actually runs inside of a JavaScript sandbox, and by default, it has access to nothing. So let's go ahead and see what this script is that we're going to be running here. It's just a greeting thing, right? It's saying like, hey, explain what ThinkingScript is to whoever's running this. Tell them there's a Git repo of thoughts. And kind of give them an idea of like, you know, all the thoughts that are in there. So let's go ahead and run this script. Go back into our terminal, and we'll run think and hi. So we run that. Oh, think. We don't want to do that. All right, so think hi.txt. So it's running. The first thing you notice is they kicked off an agent. And then, of course, it's asking us, hey, are you sure you want to access api.github.com? If you've used Claude Code, this is familiar. But the difference is this does not have access to your shell. Actually, all it's doing, the agent is just writing JavaScript trying to accomplish the task that we gave it, the task being this text. And so you can see here, the agent got that text, and it's giving us this greeting, right? It's kind of giving us a little tour of some of the things that we can run and how we can run them. So, you know what, I think just for fun, let's run the weather command, and we'll see what it comes back with. All right, so we're going to say think weather.txt, and again, it gets that thought. The agent kicks in, it starts thinking, and you know what, while that one is running, let's split the terminal here, and then we'll run this welcome command to see if it runs faster, because that is kind of the interesting thing here. We can run thoughts multiple times, and they may actually just cache. The agent kind of figures this out. So you see how much faster that was? And the reason being is because the agent just determined like, hey, there's not really any inputs to this thing, and we're just printing a greeting, so it saves it. And if you want to see where the thought is saved, we're just going to say thought open. So thought is the command line that you use to manage these thoughts. So we're going to say thought open. This is opening this thing in Finder. You can open it in your shell if you want, but I think this is just an easier way to explore. And this is what a thought looks like. So we have the thought in here. We have hi. Thoughts have memories. There wasn't much to this. So a memory is just a text file. If a thought discovers that like an API service is down, I gotta let this one go. So for example, like, hey, the geolocation failed for weather. Now here's what's crazy. This thing is trying to figure out where I am. I didn't tell this thing to geolocate. It's just kind of figuring that out. And it's failing. It's making these external API calls in the weather, and it's trying. So this thing is just trying to find something. And it looks like it did. So we found a location from whatever IP API is. Again, I didn't tell this thing to do this in the script. This thing failed. So I have to keep watching this thing as we kind of go along over here. But let's actually put this thought to the side over here while we're kind of letting this one do its thing. Yep. So we're going to try this API. And again, we can see this thing. It's just writing JavaScript, trying to accomplish the task. And finally, we have a weather report. So it's saying, hey, we got a weather report from Daly City, California. Here's the current temperature. And you know what? Let's actually look at the weather thought to see what this thing is running. This is it. This is the only thing that I told this thing to do. Figure out where I am and tell me the current weather conditions. I did not tell this thing how to do it. It's not like using geolocation for my MacBook or anything like that. Oh, I guess I did tell it to geolocate, but I didn't necessarily tell it how. It just kind of worked that thing out. The other kind of interesting thing is I'm telling this thing to cache the results for an hour. So this is kind of interesting. Like, here's how you cache stuff so it is faster. And you don't always have to cache, but sometimes you do, right? So if we run this thing, let's run weather.txt again. Let's see what happens. It should run a little bit faster, but all right. So again, our welcome thought, that one ran much faster, and there's not really any memories in here. But memory.js is the important thing that goes on here. So if an agent makes a run and it's like, hey, I don't always need to fire up an agent to complete this task, it will write to memory.js. And if we open this thing up, it's probably just going to be like a console.write or something. So what's this thing doing? It's getting the output, it's fetching it, and then it's giving us this message. And it's just writing this thing out to the screen. So it's saying process standard write out, MSG. This is the welcome message. I didn't tell this thing to do any of this. It just figured it out. I did give it a prompt. But as you can see, those prompts are pretty small. All right, so this thing is running again, and it's, if you again watch the JavaScript that it's kicking out, it's a little bit different. And it's, this one probably actually stores in memory. So let's see what the memory looks like for weather, or the thought, I guess, for weather. All right, so we're going to say thought open. And if we look at weather, it does have a memory. So this thing just takes notes along the way, and it says, oh, look at this. We have a working API. So let's read that note and see what note that it gave itself for its memory. All right, so this thing is just documenting like, hey, these weather APIs worked well, and APIs had issues. So whenever this thing runs again, if it runs into problems because memory.js is tells it to, it can just look at its memories. So it can add memories, it can change memories, it can delete memories. So that's kind of how a thought works. The security for this thing is actually done through these policy files. So if you look at a policy file, these are things that we just kind of build up over time as we're allowing things, denying things. So if you wanted to, you could write a script that would go through these policy files and make them, something where you don't care if this thing hits this website. You could just throw these policy files in there and have that stuff working. But if we look at this thing, we can see there's paths that this thing is allowed to write to. There are some policies in that are predefined. So there's workspace and memories. It can read and write to those. And of course, there's a policy. We deny that because this thing cannot change its own policy. And that's actually hard coded into this thing. You can see too, there's like these networks that we can allow. So this is the file that is pretty much telling the thing like, here's what you can and can't access. And then of course the workspace just has stuff in it. So like, here's the cache, right? We told this thing to hang on to this for an hour. So it timestamps it and puts the weather in there. Just for fun, let's put, I don't know, New York City in here. And oops, we want to run this thought. So I'm going to say think, and we run think. So it looks like it's Deutschland. I'm not sure where it's getting this input from. Probably is breaking these tokens apart, or not tokens, but these command line arguments. So like new. So let's put New York City in there, and look how fast that picked it up. That's kind of crazy. Let's try, I don't know, an airport code. So we'll try SFO. We'll see what this does. San Mateo County. Let's put, I don't know, 3 airports in. So I'm still playing around with, I need to tell the agent how to deal with arguments that are passed in. What's weird is I want that to be fast, but I need something that's fast that ideally could run local that can just tell like, hey, something's changed here. We need to deal with that. But again, like look at how quickly this thing was able to find the airport. And again, it's because whenever we run this thing, it's actually using this memory.js file and it's not running through the agent at all. So actually, let's have a look at the weather memory. So we have memory.js. And if we look at this file, let's get some syntax highlighting here in Z. All right, so here's the argument stuff. We're playing around with that. It was giving us some weird stuff there. That's still a work in progress. But anyway, we can see like this thing built itself a cache. It's storing the files there. If the cache doesn't hit, then it's trying to call out to these APIs. And again, like I didn't write any of this. The other thing that's kind of interesting too, you'll see in here, is this idea called agent resume. So if you kick off a script, it finds memory.js, it tries to run through that, but there may be times where this thing's like, hey, I don't know what to do at this point. So I get an error, I'm going to hand it off to the agent, and then the agent actually picks that up and continues. So the agent would get this and be like, oh, I see, I got this error in this memory, and it would try to complete the task. And it's not just limited to errors. Like you could have an agent resume, for example, if the arguments into this thing were over a certain amount. So that's a prompt adjustment I probably need to make here. Like it tried to do that, it's trying to look at this, but I need to tell this thing like, hey, if the arguments are over this or they change, call agent resume to kind of get out of that mess. And this is the idea here is that you kick off a script. If it's just a simple script, maybe you never need to call an agent. If it's more complicated, then maybe there's times where you need to call an agent, or maybe there's a situation where like, you can imagine an if there's a cache, do that thing. Otherwise, if there's no cache hit, then you could agent resume and give it whatever context you want, and the thing could continue. All right. So if you want to check that out and read more about this project, you should go to ThinkingScript.com. On the homepage, there's obviously the installation command. This is how you write scripts. You don't have to run these things from the internet. You can create a local file and you can run those. You're using the think command to run the script, the thinking script. The other cool thing, if you get a thought that you're just like, hey, this is quite useful, it's something I always want to use, then you'll install a thought. So I actually have thoughts that do things like, hey, I need to have get ignore files in this directory. And I can run that thought, get ignore, it'll check the project and like, hey, what kind of project is this? Oh, it's this kind of project. Here's the get ignore files it needs. So it's pretty handy for these like tasks like that. And of course, kind of the goal and the thing that I'm shooting for here is if we can run agents that coexist with programming languages, and we essentially have built executables that can evolve. Now, the cool thing about that is if you write this script, that's awesome. Anybody could write a script like this and get this data back. But the other kind of crazy thing is, let's say that an API disappears and just stops working. This thing could detect that, right? It would hit that error continuously. It would raise an error and it would say, this API is out of commission. What do I do? And it would try to find something else. So that's kind of crazy if you think about the program's not only change, but if things kind of change around them or something goes down, it will try to go around that damage. I do want to work on some way to like freeze a thought so that if you get a thought to a point, you're like, hey, this is pretty good, I like this, you could just freeze it and then it won't invoke the agent. But I haven't got that far yet. All right, so anyway, the other important thing is that you can install these thoughts. And you know what, let's do that because I think this is kind of an important concept for understanding that these things can just live as executables on your machine. So, all right, we have thought install. I got to make sure I take my arguments off of there. I don't think I've tried installing thoughts from the internet. So I do need to download this. Oops. Yeah, and I'll put this down here. So we'll run thought weather. Think weather. All right, now that was fast because these thoughts, whenever they're run, the location doesn't matter. The way that the cache is remembered is the thought is digested and that key is used for the cache. That's where all this stuff is stored. So, all right, so think install. It's going to be thought install weather. All right, so this is just telling me, hey, this thing's installed here. So if I clear this and then I run weather, there it is. So this is just a command. It's a Unix command, right? And that's the whole point of this thing. It's like if our agents can just run as executables alongside everything else, then we don't need all these orchestration frameworks. In theory, you can use inter-process communications and all these things. So yeah, you might need something to make that work. To schedule a thought though, like if I wanted a weather report mailed to me, I could just now schedule this in cron. I could create a thought that schedules thoughts for me. So I don't have to know this command to do this, right? I could just make a thought called like schedule, and then it'd be like, hey, schedule a weather command to run. You can have a mail thought. You can just have all these thoughts, and then you're just doing all these different things with the thoughts. All right, so the other kind of crazy thing, which really isn't if you have used Unix for a while, is you can pipe thoughts into other thoughts. So one other thought that I have is this table thought. And you know what? Let's just go ahead and make this table thought, right? So, all right, we're going to say z table.txt, and then we're just going to say, we'll get some data. Oh boy. Format it into a table that's suitable for display in a console. All right, let's see what happens. So I'm going to save table. All right, and then so we'll just run weather. I don't know what. All right, so weather, and then we're going to pipe that into think table.txt. So weather is going to run quick, and then table kicks off. Of course, the agent has to read that text that we just wrote. But what's cool is that weather report, that data is getting piped into this thing. Again, the JavaScript flashes up saying, hey, we got to do this thing. And here we go. We have a table. The table's not awesome. It's a little messed up. So I might have to go in and adjust that prompt and be like, hey, that didn't work. But just for fun, let's run this again, and we'll see if it's faster. So it's still thinking. Sometimes agents take a while, but they have to do a few runs before they figure out like, oh, actually, yeah, the data coming in here all looks the same. So let's just go ahead and update memory.js to not even invoke an agent. So here we go. We have the table again. That one took a bit of time to run. But I think you get the idea. This is, again, in Unix, you just pipe stuff. That's how you compose things. So if you think about this concept, right, these are full-blown AI agents. You could pipe one agent's output into another. So that's kind of a powerful primitive. This is one of those things that's been just well-known in kind of Unix applications. But I think it may be applicable to agents. Like, let's build agents that do one thing really well, and then they can hand off things to other agents. And that is kind of a form of orchestration, just piping agent output into another one. And of course, you can share thoughts. So if you have a thought, you can throw it on a gist and just send that to somebody. Be like, hey, check it out. Here's my thought. So I guess we'll just jump into security. I'll just kind of cruise through this whole page. Again, the principle here is, so one thing I got tired of just with AI agents is constantly babysitting the thing. And I know that there's all these approvals on the screen here, but where I want to get with this is like, why don't we run these things inside of JavaScript sandboxes? Maybe we give them access to some tools on our machines, and they can just kind of go nuts inside of this thing. Now, why did I not choose Docker or Apple's container runtime? I tried that, and it's just kind of a pain because you spin up these daemons, and if they're not running, you have all these problems. It also can kind of take up storage space on those things quietly. So there's just like all these issues I ran into with containers. And I was like, what is the world's biggest secure sandbox runtime? And it's this. We're looking at it. It's a web browser. I can go to just any strange website I don't trust and load it in my browser, and it's not going to take my entire computer down with it. So that's the idea behind a JavaScript runtime. And I also thought, you know what agents are trained really well on, or models? JavaScript. So I'm running inside of Goja. This was just like the easy thing to drop in there. I didn't bother with V8. I wanted to keep this thing easy to test it out. But the way that the inside of the sandbox looks is these commands are exposed to the agent. And there is a prompt telling the agents like, hey, if you want to get stuff off the internet, use net.fetch. You get environment variables, console, system. There's these things that the agent knows that it can call to get information about the host machine. Some of them need approval, others don't. Like if you want CPU or memory uptime, you don't need that. The workspaces, we looked at that. We just opened those up. This is where the agent can just put stuff like caches, or if it wants to download a package, like an NPM package, it could put it there. That's the only thing that the agent can write to by default, but it can't reach outside of that without your approval. And of course, there's the approval system. We saw that. Like here's a weather API. There's policy files. Again, we looked at that. There's different permissions you can set there. They're files so that it's easy to look at. You could audit these things if you wanted to. And of course, the whole model of trust is just based around these policies and these things running inside of sandboxes. I'm not a security expert, so like don't run your mission critical workloads inside of this thing. This is MIT licensed, so you're on your own if that happens. But just to know, like the general security model is like, let's run this thing inside of a JavaScript sandbox. It has access to nothing until approved, other than some of these directories like workspace and memory and things like that. All right, and then of course you have examples, which just shows some of the things we went through. I think the piping is pretty powerful. Obviously, like you can mix tools. If you have Unix tools, you could tell your prompt like, hey, I want you to do this thing, and then you could mix it with like JQ or something like that. So there's just a ton of like interesting little things you can do with this. I kind of chose the ones that would like go out on the internet and do things, but there's no reason why you couldn't have these little Unix programs doing like kind of local things for you. And again, you can chain all those things together and pipe them, and that's like pretty much it. But like the big idea here is there a way to build agents and to compose them using the primitives that we already have, the primitives that we've had for decades? Unix has been around forever. It's already proven. Could we just have each agent act as if it were an executable on a machine and have it run safely on that machine? And what does that open up if we can take these executables and compose them using Unix primitives? So check it out. Go to thinkingscript.com. There's a GitHub repo. There's a Twitter account. On GitHub, I think it's github.com/thinkingscript. And then the Twitter is x.com/thinkingscript. Check it out. Let me know what you think.